we are going to make golden pennies using zinc, zinc chloride, and regular pennies.
And here we got a nice little penny. It's currently brown in color because the outside coating is copper, but that will not be the case at the end of the lab.
In addition to our penny, we're going to be using some zinc. Zinc comes in these nice little bottles. Zinc is also a metal, but it's kind of a grayish metal, and this zinc we got pretty well powdered. So note that neither one of these looks gold to begin with. It's the chemistry we're going to be doing today that'll make it look gold. So if you remember from our safety video earlier in the week, number 2 dealt with wearing goggles and aprons. Whenever we're dealing with some chemicals, we want to make sure we have goggles to protect our eyes and aprons to protect our bodies.
The other thing that we need to worry about before we get started is rule number 3. I have long hair because when I lean forward, it falls forward. So I have it secured back so that I don't catch it on fire or dip it in any chemicals.
We're also, thumbs? Yeah. We're also keeping rule 20 in mind, where hot and cold glass look similar. And because we're using a hot plate today, we're going to assume all our glassware is hot. And we'll be specifically using beaker tongs to move hot beakers.
All right, the first step will be to take our pennies and we want to remove any impurities off of the front. The one of us that does this step the best will get the best results, because what you want to do, money can be very dirty, and we want to make sure that we take all of the impurities off to make sure we have a surface that's ready for our reaction. So we're going to take some steel wool and we are going to shine these pennies. We are not going to shine the pennies on our lab counters because these lab counters are very expensive because they are chemical and flame resistant. So we're going to shine them on trays and we are going to see who can get the shiniest penny.
Mine's going to be the best, obviously. Okay, so on the left, you have a penny that I shined with steel wool. On the right is a penny that has not been shined and cleaned. You can see there's a pretty big difference at this point.
So step 2 of our process is to use some zinc chloride solution. We've already got this made up here. And we're going to put that into a graduated cylinder. We use our graduated cylinder to measure the volume of a liquid. We'll teach you how to read the volume a little bit later. I'm going to put 20 mils in here. And hopefully you guys remember what this is, right? This is a pipette. A pipette's used to fine-tune things. Since I can get close to 20 milliliters. And we'll use a pipette to finish it off.
We also need to get ourselves about 1 gram of zinc dust. So I'm going to use my scoopula here. And I'm going to measure out 1 gram of zinc dust on my scale. And we're good to go.
We are then going to combine all of these into a 100 milliliter beaker. Remember, a beaker is used to hold reactions.
So now, what we're going to do is I'm going to use my forceps, my trusty forceps, to pick up a solid, and I'm going to drop it into my beaker like so.
Making sure they get a good covering of the zinc, and we are going to let them boil.
So now that we've had these pennies on here boiling for a little while, we're going to use our trusty beaker tongs to remove the beakers from the hot plate.
And our countertops here are protected from chemical and thermal energy. So what we can do is we can actually just put the hot beakers right down here. We don't want to run this under cool water or else it would cause heat shock.
And you can see that in rule number 22 from Safety Day.
All right, then what we're going to do is we're going to look in here and we are going to take a look to see if our pennies have turned silver.
Again, we're going to use our forceps to grab those pennies out of there because we don't want to touch those solids with our hands.
The pennies are very, very hot, so we're going to use a cold, wet paper towel to cool them down and to take any excess zinc off.
The idea that this guy is just coated with zinc. We want to scrape some of that zinc off, so we just are left with the silver.
As you can see now, our pennies have gone from a nice copper color here to now a silver color here. Dr. Yates, why do you think this penny turned silver?
because we put it in that zinc solution and we boiled it for a while, the zinc has gotten stuck to around our coin, turning it silver.
Oh, so it's like made a layer of zinc around
Made
it?
a layer of zinc around it, exactly.
Little zinc
Awesome.
jacket.
Yeah.
All right. This is our last step before we clean up. Now we have to take our pennies and put them directly on the heat source. We will start to notice when they start to turn gold, and then we're going to flick them off, and we're not going to touch them because they're going to be very hot.
We're going to let them cool down on those heat-absorbent black countertops.
And we're going to use our forceps to pick them up. Oh, mine's going, mine's going, mine's going. Oh, that is a golden penny.
Yours is looking pretty good, too.
Yeah, there's two.
All right, then for our second penny, we're going to give you an up close on what this looks like. So our silver pennies are going on to the hot plate.
Oh, yeah.
Mine's going to be the best.
In a few moments, you'll see them
Start to turn
transform. One of ours will look good, and one of ours will look... Oh, look who's went first. Look who's went first. Beautiful.
Mine's going to be better, though.
Beautiful.
Oh, no, you got to wait for the end.
Oh, yeah.
Slow and steady wins the race.
Okay. There we go. Oh, looking wonderful.
I think mine's good, too.
I like my pennies well done.
Alrighty. So now it's time to clean up. We have a couple different kinds of waste. Our solid zinc waste on our paper towels can go into the trash can.
And we said most liquids can go down the sink. However, this liquid cannot. We need to put this in the fume hood.
Greetings there, campers. Let's see what we've got. X, that looks like a quality penny. Quality, Abe's never looked so good. Y, looks like some quality stuff. Z, gotta tell you, it's a very close competition. But I have to say, there's one that stands out. And growing up in Illinois, Abe Lincoln means an awful lot more to me than most people. I would say this one.
Oh, I'm sorry.
How much did you pay
I'm
him?
sorry. What was that?
Recount.
Which one's the best
Recount.
one? Is it Z?
It is Z.
Is that Miss Bay? Whose penny was that?
Oh, whatever.
Whose penny was that?
Uh-oh.
It
What
wasn't-
have I started? Oh, my heavens.
It wasn't a sore loser's penny. It was a winner's penny, Mr. Pilchers. Please and thank you.
Pandemonium.
It's probably because it's Miss Bay's first year teaching.
My penny's
Okay.
great.
You can do two.
Mine's gonna win next.
Yeah, well.
Wait, put yours
sorry,
back.
our judges' decisions are final.
We're gonna need to gather more data.
We're here with local penny connoisseur, Lauren Mattiota.
And we are gonna ask her to now judge the 3 pennies. Miss Mattiota, we have now made 3 golden pennies. You may turn them over. Take the best golden penny.
She will.
Being the penny pincher that I am.
Yeah.
I would have to say Z.
Oh my goodness! Is that 2 for 2?
Oh my.
We're here with 2 more penny experts because some science teachers are kind of sore losers and they think more data will help their cause.
So here we are, and we have the normal penny. We boiled it in zinc. We heated it up to turn it into a brass alloy, and we have the 3 chemistry teachers' entries into this contest. We would like your expert opinions.
Your unbiased expert opinions.
So what looks the most
Which is the prettiest golden penny?
prettiest
Just
golden?
highest quality in your.
Highest
It
quality.
has a little dark in it.
You can pick them up too if you want.
Yeah.
That has a little dark in it. Does that?
No, this has got some kind of.
Mm-hmm.
I think Z.
Z.
Both of them? Is that 2 more votes? Hey there, Pilcher Chem folks. You want to know how to really win a penny competition? I'll let Andrew Jackson tell you how. Here you go, Bracken.
Happy to help there, Filch.
You know what to do.
Good luck.
All right, so now let's talk about the post-lab questions here in this Golden Penny Lab. So the front part of this worksheet that you can find on Schoology talks about alchemy and how it's basically one of the earliest ways to rip people off with fake gold. Pretty sweet. Anyways, if we go to the second page, let's talk about what really happened in this lab. So first up, okay, why do you think it's important to clean the penny with steel wool at first? Well, if you think about it, pennies can get pretty dirty. They're passed around all over the place. And so on the outside of the penny is a copper layer, but there can be a lot of things that get stuck to the outside of that copper layer. And in this lab, since we're trying to get zinc to lay on top of that copper, if there's anything in between, that's really going to hurt our results. So kind of what I was thinking here is to remove any impurities on the surface that will hinder the process of making an alloy with the zinc and the copper. So a couple things to note. You don't have to write down every single word I have. This is just a really thorough explanation. This is the symbol for zinc, and this is the symbol for copper, by the way, which we'll get to with the periodic table. But that's what was going on here, and that's why we need to remove those impurities. Now later, when it says, is this overall process a chemical or physical change, and why? Well, on the one hand, you could argue that it's chemical because there was a color change, and it'd be pretty hard to reverse this. It'd be pretty hard to undo. But on the other hand, you could argue it's a physical change because it's still just a penny, and it's just a mixture of a couple different metals, zinc and copper. It's not like they've chemically bonded. So the answer to this question really is yes. As long as you produce a good reason to support your answer, that's kind of what I care more about in a question like this. Now here, why do you think you have to heat the penny in step 7? So this is where we took the penny and we plopped it directly onto the hot plate. In the video, this is where the penny started with like that silver color, because the zinc was on the outside, and then it ended with the gold color. Well, what was really happening in there was that hot plate was melting the copper and the zinc together to make an alloy. And that alloy, the gold, quote unquote, is really just brass. That's what it really is, which is often used for handles, like door handles and that kind of thing. So what is an alloy? You've said this word a couple times, Mr. Pilcher. Well, an alloy is just a mixture of any metals. The alloy we made in this reaction is brass, and the two chemicals, like I've said a couple times now, were zinc and copper that make brass. This next question was an interesting one. It's like, okay, so would this process work for a quarter? Like, can I get like a gold quarter type situation going? Well, no, you can't, because quarters are made out of nickel, not copper. So pennies have that copper on the outside. That's the main ingredient in brass. And if you don't have copper, you can't make brass. The sixth question. So if I cut the penny in half, will I see the gold color all the way through? Maybe pause the video for a second and think about that one. Will the penny be gold all the way through? So the answer is no. Remember, we just put that zinc coating, the silver color on the outside. We just got that to kind of coat on the outside. So when we melt that with the copper, it will look gold all the way around the outside, but that doesn't mean the inside is gold all the way through. So no, if you cut a penny in half, the zinc melted to the surface of the penny only. So you're not going to see gold all the way through. And lastly, again, I'll probably pause the video for this one, but I want you to think about what's going to happen to that mass of the penny. Normally in lab, I have you guys get the mass at the beginning of lab and then at the very end. What do you guys think you would find? Would the mass go up, down, or stay the same? So the answer to this one is we should definitely see that mass increase. If you think about it, you know, we're adding a layer of zinc, okay, to the penny, which adds mass. So we had a penny, we slapped some zinc onto it, but there's more stuff on that penny, and so its mass should go up just a little bit. And if you do that, you do actually look at the mass of the penny before and after, it does in fact go up. Alrighty, folks. Well, this ends all the information that could possibly be on week 1's quiz tomorrow. So make sure we're ready to rock. That
Good enough.
looks good. Look at the, what does it look like there? It looks good to me. kind of cuts off the point of my head, but you gonna rub your hand off?
Yeah, okay. I like to just be able to give it some, give if I need to. Or so mine get better than yours.
You'll notice that some science teachers' pennies will be good, and others will be, I believe the proper term is whack.
Did you just say whack?
That's one of their terms. You
Is-
gotta
they
stay
are
up to date. You gotta stay up to date.
You're so hip,
Oh, I
Mr.
thought that was a
Quilter.
technical term.
Whack.
Whack, it's both.
Oh, I got the pennies that were dirty to start with.
I grabbed a dirty one to start with.
That's not true.
I did too. Look, there's still crap on it.
I can't get it off. What if none of us have a good penny?
Learning
We're
curve.
going to use a spoon.
Oh
Get
my-
out of here. I don't have any scupulas and
What?
spatulas in here.
Why do we even talk about them, Bay? Oh my.
God.
So we're dealing with micrograms, maybe, but
Oh my God. What is he doing? I don't even know. Screaming about a scupula.
our step one in our procedure is to
Step
take
2. Let me
step.
flip this around. We just did 3. We're about to put a solid in there.
I was for a second, and then wait a minute, I'm not
Hey,
JJ. I
wrong,
don't do it that way.
Wrong.
Oh, we got to keep this because we can do this in the fume hood.
Nice. Well, that's embarrassing for you.
That's amazing, dude.